Hello, Bio4, and welcome to part 5 of respiratory. We're now getting to the alveoli. We've gone down all the bronchi and down into the bronchioles, and we've reached these little grape-like structures that are going to be the site of exchange. So take a look here at venous blood coming down. So it's deoxygenated, it looks very blue. And then it's branching out here on a capillary bed that's picking up as much oxygen as possible and converting it to red here because now it's oxygenated and will then travel on and reach the left side of the heart and will be off to irrigate all the tissues, right? So you get the idea of how this is vastly irrigated. You want that venous blood to be surrounding these little alveoli so that they can pick up as much oxygen as possible. So I'm telling you here that the alveoli, they are the site of gas exchange. Each is closely associated with a capillary. I've told you all this. But then let's think of the respiratory membrane itself. So you have to think of the wall of the alveolus plus the wall of the capillary that's sitting right on top of it, right? And those two together are going to be the respiratory membrane. And gas exchange is going to occur by diffusion. It's going to go from where there's more oxygen to where there's less oxygen. So if there is more oxygen in a region of a capillary bed that's irrigating a tissue, it's going to go in that direction. In the alveolus, it's going to be higher in oxygen, so it's going to go from the alveolus into the capillary, and it's going to get picked up. So in this very simple drawing, I would draw an alveolus, and then you would have that vessel, right? That capillary bed that is in such proximity here. And imagine this, you have one cell thick, the wall of this is just one cell, right? You have lots of cells that are making up the alveoli and making up the little balloon, but that oxygen is going to have to cross the one layer of the one cell layer of the alveolus and then the one cell layer of the capillary, and this is that membrane that it has to cross. And remember that if we are really high in oxygen here and not so high in oxygen in the venous blood that's coming in, then by diffusion it's going to go from where there's a lot to where there's very little. This is a much better picture than the one I drew. And there you have again air in the alveolus. It's made up of, look at this cell. This cell is making up the wall of that little balloon, that little grape, right? And then there's the wall of this, here's another cell that makes up the wall of the capillary. So you have two walls that need to be crossed, which is very thin when you think of it because it's one cell thick. So one cell, two cells, and this is going to, from air into the blood, we're going to distribute oxygen. And then we're kind of high in carbon dioxide in venous blood here, so, and lower in the air that you inhaled. So it makes sense that through diffusion, carbon dioxide is going to move from where there's a lot to where there's less. And you're going to be able to exhale it out. Okay, that's the respiratory membrane. This is a true photograph of it, scanning electron micrograph, so it's an incredible magnification. You can see the tiny little structures that are going to be receiving that oxygen. So let's look at that epithelium because it contains different types of cells. So the first type of cell that's the most predominant, that makes up my little balloon or makes up my little grape, is type 1 cell, and they're called squamous. They're flattened out, just like the squamous cells you drew, and they're going to allow that diffusion of those gases. The second type of cell is not as frequent. It's type 2 cells, and these cells are very important because their job is to secrete something called a surfactant. And a surfactant is kind of like a soap-like structure, and what that chemical is going to do is going to lower the surface tension. What's that mean? Imagine this little microscopic little balloon, right, or grape, that's very moist inside, and it has no muscle in those walls. So it could very easily collapse on itself and stick. Anything wet, imagine a pane of glass wet on top of another pane of glass, how they stick, and it's impossible to get those unstuck, right? So you don't want that to happen in these little microscopic alveolar cells. So we secrete this chemical that is gonna sort of remove the stickiness of those walls, and you don't have collapsing alveoli. The third type of cell are macrophages, and this is an entryway to the body. Remember, you have air coming in. They could be coming in with bacteria and carbon, all sorts of nasty things. So you have macrophages. These are specialized cells that are going to patrol and remove nasty stuff. Okay, so let's go back. Squamous cells, greater alveolar cells, and macrophages. In a diagram, here's a greater alveolar cell. It's secreting surfactant. A macrophage, it's larger cell and can patrol around and find anything nasty around here. And then the type 1, the majority of squamous cells that just make up this tissue of the alveolus. Preemies are an interesting story to look at because babies may not be manufacturing enough surfactant if they're born too prematurely. So any baby born before the 31 weeks out of the 40, they are not producing enough surfactant. So that needs to be administered to them. It's administered through a little tube into the lungs several times a day, or the baby has to be put on a respirator. So very important for preemies that can't yet breathe on their own. And it's because of the lack of that surfactant. Let's stop this here and then we'll move on to the lungs. Thanks for listening. Bye.